In this video, we shall continue creating our hierarchy of classes that are in the end going to represent the various game items that we can have in Space Fighter. Specifically in this video, we're going to be creating the ship class. This guy's going to be very simple. He's more or less just going to be an extension of game node that's going to be left empty. We will revisit it a little bit later in time when we add weapons into everybody that's on this side, which is pretty cool because obviously player ships need weapons and enemy ship need weapons, but asteroids don't. But since they're tied into all of this, we can make asteroids have weapons, which makes the game very interesting. But once again, we're going to leave ship pretty much empty at the moment. We're just going to simply extend game node with it. Then we're going to focus in this video on the player ship class. So there's two classes that we're going to be creating in this video. And then with the player ship class, several things that we're going to set up. We're going to need to go back over to our config class and create the sprite sheet representing our ship. We're going to need to create a couple of configuration fields, if you will, just some pieces of information for the ship, like the ship speed, the ship health, a ship spawn offset that you guys will see as we spawn a ship in, how he needs to be moved up on the screen. And from there, we're going to start with the field that we pointed out right here. We're going to need that static list that we can maintain all of our players in. Then we'll move into the constructor. And from there, everything that we're going to do in this class is stuff that you have seen in the past, such as, go ahead and create a ship, make sure that ship gets added into the static list, go ahead and set its speed, its health, based off of what's over in the config class, and then go ahead and get its position set up. Then we've got to remove. The remove method is interesting because remember at this point, all the way back up here at node, we are maintaining a flat list of all of the nodes that are created in Space Fighter. And if we end up getting removed from this list, we also need to make sure that we are removed out of this list. So a little bit of list maintenance, if you will. So we will be setting up a remove method that will make sure we are removed out of both lists if we need to be removed. And then we're going to spend just a minute on an update method, where this will, of course, be an override coming from above. And what we're going to do is call first the update so that we get moved, because recall as we work our way back up the chain right here, we get the move updating our node position, but then we need to make sure that we weren't just moved off screen left or right. If we were, we need to snap back on screen. So basically do the update and then fix any sort of off-screen movements before a draw occurs. Okay.
And one last thing I do want to point out is that even though we're getting the player ship class itself ready for use, we won't actually be able to put it into use in the game just yet, and that is because we don't have input ability just yet.
That's right.
So we won't actually see them in use until a little bit later when we get the player class put in.
Oh, but that's coming up really, really soon. So let's go ahead and jump on over into Visual C# and get started.
All right. This ship class is going to be placed into the game folder. So our new class will be called ship. And this class is going to be the absolute bare minimum necessary to define a new game node. We're going to strip the game, game sub namespace. I'm going to remove the using text, even though I guess that's irrelevant at the moment. The ship is going to be extending game node, and now since it's extending game node, we are obliged to provide a constructor that will properly chain to the base constructor, so we will drop this in as well. We'll have a public constructor, ship, that takes in a sprite sheet. We'll name that parameter sprite sheet, and we will chain this to the base constructor, and we'll simply pass along the sprite sheet. And I'll provide the implementation as an empty body with the curly braces. And that, as a matter of fact, we don't even really need collections either. And that is the ship class, for now anyway. Like you said, we're going to come back to it in later videos when we start needing weapon systems. But for now, we have the class established, so we have the proper organization in the hierarchy.
All right. So the next thing we can do is two different directions we can go. Let's go ahead and create our player ship class and do some quick cleanup, and then jump over to the config class and start adding in the information we're going to need back over in player ship.
Okay, let's begin in the game folder then. Let's add a new item, and this item will be the player ship class. I'll add this in, fix up the namespace, take out the using for text, and let's drop in a using for the XNA framework namespace. Using Microsoft, and we probably have some fun with spelling, so I'm just going to retype that. XNA framework. Perfect. Playership is going, and we can throw in the basics for the class. One, playership is going to extend ship, and I'll worry about the constructor a little bit later once we start getting into fields.
Okay.
Now from here, the playership has several configurable parameters that we want to set up, beginning with the sprite sheet itself for a playership. Other things include the ship's speed, how fast can it move on screen, and how much health does it have when it spawns. And we're also going to set up an additional offset. I'm going to spawn the player ship at the bottom of the screen, but I'd like it to be moved in a little bit off so it's not resting on the bottom pixels of the screen. I'll place this offset into config as well. So let's jump over to the config class, and let's jump down a few lines below our asteroid sprite sheet. And here we'll define a ship sprite sheet. This will be a public static field. It will be a sprite sheet, and we'll call this ship sprite sheet. And we'll turn around and make a new instance of sprite sheet. Now, what should be the asset name? Well, just in case we had forgotten what our names were, like I did just a second ago, we've got ship 1, 2, 3, and 4. And we'll discuss how to set up and automatically associate different player textures with different actual players once we get done with the input section.
Okay.
For now, I'll just grab ship 1 and we'll use that for ship sprite sheet. So we'll place ship 1 as the asset name, and now we can specify the rest of the information for that. If you'd like, we could go and grab that original graphic, but as you saw from the first video, all we need to do is go to our source images folder and count off the tiles in X and Y, which I know from experience are 4 by 3. We'll specify a frame rate of 12. We'll make this a little bit slower than the asteroid because we have fewer frames, and that gives the motion for the engines that I wanted.
Right.
So we'll finish off this call to our sprite sheet, and now we can put in the rest of the parameters for speed, health, and spawn offset. For these, we're going to have, beginning with ship speed is a float. So we'll drop down public static float for ship speed, and ship speed will be a value of 6. And to speed things up a little bit, I'm going to copy this line, paste it 2 more times just so I don't have to keep typing public static over and over again. The next field of interest is going to be the ship's health. This will be an integer that we'll call ship health, and we'll set this value to 100 at spawn. Now finally we have a vector 2 to represent our spawn offset. So static vector 2. Now notice that we don't have the vector 2 type available at the moment. That is because in config we have yet to add the using for XNA, which I'm going to steal from playership. With this using Microsoft.xna.framework, the vector 2 type becomes available, and that's what we'll use for ship spawn offset. And we'll set this to a vector 2, new vector 2 of 0 by negative 20. So what's that going to do? Well, move us not at all in X, but move us up in 20 pixels. Alright, now I've got some configuration set up to describe how a ship should work. Now let's move back over into playership, and let's finish off its implementation. Beginning with fields, or in this case, the field. As described on the whiteboard when we covered game node, we need a static list of all player ships that will be used for enemies or anything else that needs to collide with players. So here's where we'll put that into place. It will be a public static list of type game node. And we're going to call this list player ships. And we'll go ahead and initialize the list as well to a new list of game node. And I do want to point out and stress the fact that the type of this list is game node. It's not of type player ship. It's not of type ship. The reason it is of type game node is to keep that high level and generic enough that that can be passed around to anything when we try to describe collision lists. We have defined it as a rule that collision lists are lists of game nodes. not anything more specific. That always ensures that we can always set anything's collision list to anything else.
That's right.
And that is the sole field that we're going to have in player ship for the time being. So let's drop the constructor into place. This is going to be the public constructor for player ship. And just like all game nodes, we need to take in a sprite sheet. So we'll give a sprite sheet, name sprite sheet. Sprite, right, that's too many sprites. And this will be chained to the base constructor, passing along the sprite sheet. And then we can put in the body for the constructor. Very first thing we need to do is to make sure that this ship gets added into the player ships list. So we'll take player ships, we'll add in this instance. Now, a few more things we need to set up is we need to grab those fields that were set up inside of config and use them here. So that means we'll set up things like our game node's speed. So this player ship game node speed will be set to a value of config.shipSpeed. This instance's health is going to be set to a value of config.shipHealth. And this instance's position is going to be set to a new vector 2. And this is where things get a little bit more interesting. It's tempting to just drop in, ship spawn offset, perfect. No, we'll spawn off the top left corner of the screen a little bit up in the sky. We actually need to derive the center of the screen, position ourselves there, and then we'll add ship spawn offset, well, using addition as an offset. So the new vector 2 is going to describe the center of the screen in X and the bottom of the screen in Y. So to grab the center of the screen, we'll divide the screen width by 2. Screen width is found in config. We have config.screenWidth. Divide that by 2 to give the center. For Y, we'll take our screen height, config.screenHeight, and we'll subtract this instance's sprite's origin Y. And the reason we do this is to make sure that we don't spawn halfway cut off at the bottom of the screen. We actually move ourselves up on screen by however distant the origin is. So minus this dot sprite dot origin dot Y. And to this, we will offset by our ship spawn offset. I'm actually going to jump down to the next line to put that in place. So plus config dot ship spawn offset. And that
which will
should
push
take
us
care
20
of,
pixels further up.
Exactly. And that also takes care of our constructor. Now let's move on to some methods. There's no new methods defined here, but we are going to override 2 of the existing methods from node. First of those is remove. So if we override the remove method, we'll leave our call to base.remove in because we still want remove to work in a recursive nature back up in node. But what we're interested in with this remove override is to make sure that the player ship gets removed from the player ships list. So we'll take player ships and remove this instance. If we fail to do this, we could possibly run into a scenario where the ship is removed from the main node list, meaning it stops being drawn, but is left in the collision list, so other things would suddenly be colliding with this blank spot in space.
Right.
So we need to make sure that we clean up the player ships list whenever a player ship is removed. Alright, this leaves just one more method. Now we're going to override update to make sure that the player ship is locked to the playable area of the screen, making sure that if the ship wanders off screen, we automatically snap it back on screen before a draw occurs. So we're going to override the node update method, and instead of moving base.update to the bottom, we're actually going to run it before our own code, because keep in mind, base.update is what's going to cause our player ship to move based on its speed. Once it moves, it could have potentially just gone off screen. So we're going to quickly, right after that move, lock it back on screen before any draw calls appear. That way we never see it jump off screen before getting corrected. Now the check to make sure that it's on screen is going to be very similar to a lot of past projects, including ones where we just had a circle bounce around the screen. We'll check the left edge, the right edge, the top edge, and the bottom edge, and if we're off any of these edges, then we'll simply snap ourselves back up to the edge of that, or whichever edge of the screen that was. So beginning with the left edge of the screen, we'll make an if statement and see if this dot position dot x is less than our sprite's origin. This dot sprite dot origin. Again, the reason we're placing origin in here instead of 0 is because we'd actually, origin dot x. We can't subtract an entire vector 2 against an integer, or excuse me, a float. It just won't work. But again, the reason we're using sprite origin x instead of 0 is if we had used 0, then we're going to be colliding at the center point. We actually want to be colliding at the visual edge.
That's right.
So we're looking for this value instead of the 0 value. If we have gone off screen in that direction, then we need to snap ourselves back to that value. So we'll say this dot position is equal to a new vector 2, where we will set the position in x and preserve the position in y. So that is this dot sprite dot origin dot x. And so with this origin x, we have just snapped ourselves back on screen, but because we're making a new vector 2 to satisfy the vector 2 property, we also need to specify y, and we'll simply preserve that. So this dot position dot y, unchanged. Now if we haven't gone off the left side of the screen, then it's possible we've gone off the right side of the screen. So we'll say else if this dot position dot x is greater than config dot screen width minus this dot sprite dot origin dot x. So once again, checking the other side of the screen, but properly offsetting for our origin. If we have gone off screen in that direction, then we need to snap ourselves back on screen. I'm going to copy the line where we reset position from the left side of the screen. We'll paste that in, only this time we're looking for screen width minus sprite.origin.x. So I can simply snag this code, paste it in, and we should snap back to the right-hand side of the screen. Now, if neither of those cases were hit, we need to do, or irrelevant of those cases, we also need to do checks for the top or bottom of the screen. So to do those checks, since the code is very similar, we just swap x for y and width for height. I'm actually going to copy the entire code block, paste it in as a second if-else set, and we can begin with the top of the screen. So we're checking our position y to see if it has gone less than our sprite's origin y, and if that's the case, we'll set our sprite position, but only this time we'll preserve this dot position dot x. We'll set this dot position dot y equal to this dot sprite dot origin dot y. So just swapping what we were doing with x and y. And then the same thing for the bottom of the screen. If our position in y has gone greater than screen height minus sprite.origin.y, then we need to reset our y direction to this value, config. The screen height minus the origin in y, and we'll simply preserve our position in x.
Wait a minute.
And then we've still got a screen width versus a screen height. So now if all of that is correct, y, preserving x, preserving...
No. Yeah, we just want to...
remove that all together. I see.
Cool.
And that should take care of it. Now, once again, we can't test this yet until we have input in place. So...
For any typos, we'll have to revisit it, which we'll find out about real soon.
Any typos will just have to wait. I will build, make sure that there's no simple syntax errors, and everything appears to build just fine. So
excellent.
That is what we needed to get accomplished inside of Playership.
All right. So with that, that is going to wrap up this video. Thanks a lot.